Hi there, Mr. Sutton here, bringing you the AB Calculus 6-7 homework answers on total distance. On this problem, we have a particle that starts at rest and goes on a line in such a way that its acceleration is 24 t squared feet per second squared. We want to know how many feet this particle moves through during our first 2 seconds. So at some point, I'm going to have to take some kind of integral of velocity to get some kind of distance. Is it going to be displacement versus total distance? We don't know yet, but we need a velocity formula at the very least to get this thing started. So we have kind of an unwritten acceleration formula of a of t equals 24t squared. And now to take the antiderivative of that, we're going to do some Diffie-Q magic here to get velocity. We've got v of t on the left, and this bumps up to a 3 for the power. Divide by that, we have 8t cubed on the right, plus c. Now we have to find out the c value by plugging in the initial velocity. What is that? Well, they told us that at time 0, our particle started at rest. They're saying the velocity is 0 at time 0. So we have 0 equals 8 times 0 cubed plus c. Everything zeroes out everywhere, so we just have c equals 0, meaning our velocity formula is none other than 8t cubed. Great. Now, before we just go ahead and take the integral of this thing from 0 to 2, we have to make sure there's no direction changes, because they asked through how many feet does the particle move. And if there are direction changes, then the total number of feet moved versus the displacement, the change in position, are going to be different things. So looking at this function, this is just a cubic function with a positive out in front. If I plug in any t value larger than 0, I'm going to get a velocity larger than 0. Since velocity is positive for all t values that are positive, which is really the only ones we care about because time is positive, that means that there are no direction changes. We're going the same direction throughout. So we can just turn around and take the antiderivative now of velocity, or take the integral of velocity, I should say, from 0 to 2 seconds. And this is the next phase of the problem. Again, no calculator problem, so we're doing this by hand. Antiderivative of 8t cubed, this bumps up to a 4. Dividing by that, we've got 2t to the 4th. And we're evaluating that from 0 to 2. Now this isn't so bad. We have 2 plugged into this thing minus 0 plugged in. Well, that second term is just 0, so really it's just 2 to the 5th power here, which is 32. So that's 32 feet, giving us answer choice A. For this problem, we have a graph of the velocity of a car between 0 and 8 seconds. We want to know which is the best estimate of the distance traveled by the car from time 0 to the time when the car comes to a complete stop, which is presumably at time 8. So in order to figure this out, first off, since we're talking about the distance the car actually traveled, we're talking total distance, so we have to figure out if there were any direction changes along the way. Since our velocity appears to be positive throughout this whole interval, that means that we definitely have no direction changes. This car is going the same direction the whole time. It's just a question of how fast it's going there. So we just take the straight-up integral of velocity from 0 to 8, and we unfortunately don't know the exact velocity function. We have a picture of it here, though, so we can approximate this by trying to find the area under the curve here. Now, we could do this with a bunch of rectangles, and that's certainly one way to do it. Probably the fastest way is just to do a triangle from here to here, like so, and then see the area of that triangle. So this is going to be 1/2 times a base of 8 times a height of 50. So that's 4 times 50, which is 200. And is 200 feet over or under? It's going to matter because we're pretty close with answer choices C and D. None of the others are really close, but over or under is going to make a difference here. So taking a look at this here, we're crossing about halfway through this function, and it looks to be fairly symmetrical, but it's a little bit lopsided. This side, there's more white space than there's shaded in extra space over on this side. So it appears that we have a slight underestimation just comparing these two little curvy parts here. If it's a slight underestimation, that means that choice D is going to be a better option. On this problem, we have a particle moving on the x-axis with a velocity given by this rational function. We want the total distance traveled by the particle from 0 to 2. Well, since this is a calculator problem, we're just going to use our calculator and plug this into it as y equals. And since this is a total distance problem, we want to take the integral from 0 to 2 of the absolute value of velocity, like so. So let's go ahead and plug that in the calculator. So there's my crazy looking function plugged into y equals. Let's quit out of that now, and I'm going to do the integral from 0 to 2 of, and now I need absolute value, so I'm going to do alpha window, and that brings up this little menu with abs. And now I'm going to put in, let's see, alpha trace y equals 1, or y1 there, and we'll do dx. So I'm just taking the absolute value of this thing and integrating it from 0 to 2, and that comes out to about 0.927, which gives us choice D. On this problem, we have a particle traveling on the x-axis, so the velocity is given by this formula. We want the total distance the particle travels from time 0 to 3. Well, if we're asking about total distance, then we need to figure out if we are changing directions anywhere on this interval, because if we are, the total distance and the displacement are going to be different. So let me factor this out and set it equal to 0. So I can factor this into t minus 2 and t minus 4, and all of that equals 0. That gives us critical values of 2 and 4. Just doing a little bit of mental sign analysis here. If we plug in, let's see, plug in 1, we get a positive. If we plug in something between 2 and 4, like 3, we get a positive, negative, so negative. So we definitely have a direction change at t equals 2. And also, maybe possibly also at 4, but we don't really care about that one because it's outside this interval from 0 to 3. But because we have a change at 2, we're going to have to split my integral up. So I'm going to be doing total distance equaling the absolute value of the integral from 0 to 2 of my velocity function, but I'm also going to have to add the absolute value of the integral from 2 to 3 of my velocity. The only good news here is that it's the same formula in both places, you're just plugging in different numbers. So taking my antiderivative, I've got, let's see, this will be 1/3 t cubed minus, let's see, divide by 2, so 3t squared plus 8t. And we're evaluating that from 0 to 2, and also the exact same thing from 2 to 3. Well, this is going to be a little bit of a mess. We've got all of this stuff with 2 plugged in, minus all of this stuff with 0 plugged in, and all of that is in one big absolute value. Next, we have all of this stuff over here, which is the same formula, with 3 plugged in. So this is just a continuation down here of this long chain of arithmetic. And now we're subtracting all of this stuff with 2 plugged in. All right, it's arithmetic time. This was a no calculator question. The good news is all this stuff with 0 is gone, but we still have to calculate this stuff over here. So let's do the easy stuff first. We've got, let's see here, this is 16, and this is negative 12. So that's a grand total then of 4. So we have 8 over 3. And then plus 4. So 8/3 plus 4/3, no, 8/3 plus 4, that's going to be 8/3 plus 12/3. That's going to be 20/3. And again, this stuff went away, so we just have the absolute value of 20 over 3, which is just 20 over 3. Now for this stuff down here. This stuff inside the first bracket here, this is going to be, let's see, 9 minus 27 is negative 18. Plus 24 is going to be positive 6. So we have 6, and this is another helping of 20 over 3 over here. It's the same thing that we got for this one. 6 minus 20/3, that's really going to be 18/3 minus 20/3, which is negative 2/3. All right, so this is 20 over 3 plus 2 over 3, because absolute value. So that's 22 over 3 for the final answer, choice D. For this problem, we have a particle going in a straight line with a velocity of t squared. We want to know how far this thing moves between times 1 and 2. Okay, well, the first question is, does it change direction at all on this interval? In which case, how far it moves versus how much the position changed might be different answers. T squared is positive for all t values. So since our velocity is always, or at least it's always at least 0, right? It's non-negative. This means there are no direction changes. And we can just take the integral of velocity from 1 to 2 without any other kind of changes. So going ahead and doing that, antiderivative, I've got 1/3 t cubed, evaluated from 1 to 2. So we have 1/3 2 cubed minus 1/3 1 cubed. This is going to be 8/3 minus 1/3, which is 7/3, giving us choice B. For this one, we have the velocity of a particle given by this formula here. We want the average velocity of this x-axis moving particle over the interval from 0 to 3. So this is a pretty straightforward average value kind of problem. We've got 1 over the interval length, so 1 over 3 minus 0, times the integral from 0 to 3 of whatever we're trying to average. In this case, that's the velocity. So we'll just do v of t dt. No need to rewrite it. They already gave it to us here. But I'm going to do all this on my calculator now. So I start by entering this formula in my y equals here, just to make my life a little bit easier. And now I'm going to do, let's see, alpha fancy fraction. We've got 1 over 3. And then math 9 integral from 0 to 3. And I'm just taking the integral of that y1 function I just did, so alpha trace to pull up my y equals menu, dx, and that all comes out to about 20.086 if I round off to 3 decimals, which gives me answer choice A. On this one, we have a particle going along the x-axis with a velocity given by this v formula here for time greater than or equal to 0. If our particle starts at -2 for the x value at time 0, we want the position at time 3. This is just a straight up where am I kind of question, a position question, so we don't have to worry about absolute value or anything like that. If we want the position at 3, that's just going to be the position at 0, namely -2, plus the integral from 0 to 3, because those were the times of our velocity formula. But this was a no calculator question, so we had to do this by hand. Antiderivative of v, that's going to be, let's see, t cubed minus 4t, all integrated from 0 to 3. So this is -2 plus, and now all this stuff with 3 plugged in, minus all this stuff with 0 plugged in. The good news is that all this stuff with 0 plugged in is just 0. So we just have -2 plus this first bracket. This is inside here 27 minus 12, which is 15. So -2 plus 15, which comes out to 13. Choice A. On this question, we have a particle going along the y-axis with this velocity here. For this part of the problem, we want the position of the particle, y of 2, given that we have an initial position of y of 0 equals 3. So we're basically using FTC on this one. We're going to say y of 2 equals y of 0, namely 3, plus the integral from 0 to 2 of our velocity function here. And for this, we just go to the calculator. So just to make my life a little bit easier for the rest of this problem, I'm going to enter my velocity function in my y equals here as y1. And now quitting out, I want 3 plus the integral from 0 to 2 of, and I'll just call up y1 here from my alpha trace submenu, and then dx. That all comes out to approximately 3.827. And they didn't give us any units, so we're not going to give them any units. For this part of the problem, we just want the total distance traveled by our particle from time 0 to 2. So I'm just going to take the absolute value of my velocity function, which I can just write as v of t, and integrate that from 0 to 2. And absolute value is going to be inside the integrand here. So let me just use the calculator again. So recall that I had my velocity function stored as y1. So I have integral from 0 to 2, absolute value of y1 dx, in this case, because the calculator always uses x. And it takes a little bit of time to get this done, but we end up with 1.173. For this problem, we have a particle moving on the x-axis with a velocity given by this function here, and we're starting at x equals -2 at time 0. For this part of the problem, we want to know on the interval from 0 to 12, which is what the problem specifies up here, when is the particle moving to the left? So we need to look at a little sign analysis of our velocity function. This is a no calculator problem, so we need to figure out the places where velocity equals 0 without a calculator. So I'll start by setting my velocity equal to 0. And now to solve for t, I need to take the inverse cosine of both sides. if I take the inverse cosine of 0, I'm basically asking at what angle do I have an x value of 0? Well, that's going to be anywhere on the y-axis. So, for example, at pi over 2, 3 pi over 2, 5 pi over 2, etc. And when I get rid of the cosine, I've still got this pi over 6t that was left inside. So now to actually solve for t, I need to multiply by 6 over pi. So I'm essentially going to cancel out all these pi's here and multiply all the numerators by 6. So I've got 6 over 2, which is 3. This is going to be, let's see, 18 over 2, which is 9. And then 30 over 2, which is 15, and so on and so forth. So the only ones I really care about are this 3 and this 9 because those are on the interval from 0 to 12. Let me do some sign analysis now. I've got a number line. This is my velocity number line. I've got the endpoints of 0 and 12 that I'm going to put on here, and also these critical values at 3 and 9. Testing now a value between 0 and 3, such as 1. If I plug 1 into my velocity, I'm doing the cosine of pi over 6, essentially, which is going to be positive. And then a number in between 3 and 9, such as 6. It's a good one to plug in. If I do, let's see, 6 for t, that means I'm really doing the cosine of pi. That's the left side of the unit circle, so that's a negative because it's x values. And then a number between 9 and 12, like 10. Well, now I've got, let's see, 5 pi over 3, essentially. We're still on the left side of the unit circle. So again, well, actually, hold on, where are we? No, 5 pi over 3, that's 300 degrees. That's the right side of the unit circle. So we are, again, positive. All right, so looking at this, if I want to know when the particle is moving left, I need to see where velocity is negative. Because on the x-axis, left is negative, right is positive. So I noticed that my velocity is negative on the interval from 3 to 9. Therefore, my particle is moving left on the interval from 3 to 9. For this part of the problem, they want us to write but not evaluate an integral expression with the total distance traveled by our particle from time 0 to time 6. Well, they actually were very nice to us on this one, because for total distance, I just need the absolute value of velocity inside an integral. So essentially taking the integral of speed from 0 to 6. So that's going to be integral from 0 to 6 of absolute value of v of t dt, and that's it. Hey, write but do not evaluate, sold. On this part of the problem, they want the acceleration of our particle at time t, and then they want to know if our speed is increasing or decreasing or neither at time 4. So first we need to write the formula for acceleration. That's going to be v prime of t, which is going to be, let's see, we have a tail of pi over 6, so pi over 6 times negative sine pi over 6t. Now that we've got that formula, we need to figure out what the velocity and acceleration are doing at time 4, because we need to compare them to see if this thing is speeding up or slowing down. So velocity at time 4, that's going to be cosine of pi over 6 times 4, so 4 pi over 6. That's cosine of 2/3 pi, and let's see, that's going to be cosine of 120. That's a reference angle of 60, so it's really 1/2, but we're on the left side of the y-axis, so that's negative 1/2. So unit circle is going to be helpful here. At the very least, you could have said, though, that this is negative, even if you didn't identify it as being exactly negative 1/2. Next, we need acceleration at time 4, so we'll plug 4 into this formula here. So we now have the sine of 120 degrees, essentially, reference angle of 60 still. So that's going to be positive root 3 over 2 times negative pi over 6. So that's negative pi root 3 over 12 when all is said and done. But really all we care about is that this is a negative value. Since the velocity at 4 and the acceleration at 4 have the same sign, this means that our particle is speeding up at time 4. For this last part of the problem, we want the position of our particle at time 4. Since we have the velocity and an initial x value, we're going to essentially use the fundamental theorem of calculus for this one. So I can say that x of 4 equals x of 0, which is negative 2, plus the integral from 0 to 4 of our velocity. All right, so to actually put some numbers in here, we have negative 2 there, and now I need to take the antiderivative of velocity. So that's going to be, let's see, sine of pi over 6t divided by pi over 6. So that's going to be 6 over pi. sine of pi over 6t, evaluated from 0 to 4. So I've got negative 2 plus all this with 4 plugged in, minus all this stuff with 0 plugged in. So if I do sine of, let's see, essentially 2/3 pi, that's essentially sine of 120, which is going to end up being radical 3 over 2. So we have 6 root 3 over 2 pi, which is just going to be, let's see, 3 root 3 over pi. 6 and 2 cancel out, so that's just 3 over pi there. And now for this next one, we have, let's see, sine of 0 essentially, which is 0, so we'll take that one for free. So when the dust settles then, this is our final answer. Now, since this is free response, you actually could have stopped right here because the sine or cosine of a constant is considered a constant, but if you took it all the way, this is what you'd end up with.